everyone. Welcome back from the break. Where we're at the moment is that we're about to jump into Python data structures 2.2. I will just quickly comment. A few people in the chat pointed out something I didn't know about GitLab. I don't use GitLab outside of this course, which is that if you go to repository and then you go to graph at the bottom here, you can actually see the Git commit history here. So that's fun. Check that out. The thing about commits, which is funny, is you can't actually remove commits from a repo. It's a bit complicated, so you actually see stuff here from like ages ago. This is all like a year plus ago. Huge amount. Anyway, super interesting. Big interesting stuff. Anyway, let's get stuck into it. So I think this might be all we get done today. Previously in this course, in the past, we used to not teach dictionaries in week 1, and then we would do a whole lecture on dictionaries in week 2. What we changed this term was that we wanted to teach dictionaries in week 1 because it's really hard to even understand the assignment without it. So we said let's teach dictionaries a little bit in week 1, and then in week 2 we can actually go through dictionaries in more detail and go through lists in more detail. And then what happened was we said, well, actually what we're talking about here is a broader topic in Python, which is known as collections. So Python collections are a set of core libraries that are all about managing data. And in particular, these data structures are lists and tuples and dictionaries, which we talked about last week in a very light detail. And then there's sets, which are super uninteresting, exactly what you'd expect, and we're not going to talk about those very extensively. Oopsie daisy. Shouldn't touch this once it's... Sorry. So... there we go. That'll do. Okay. Why do we want to talk about these things? Well, we want to talk about these things because it's like most of what you do in Python, honestly, is just manipulating lists and other kinds of structures. Like it's just a really common thing to do. So if you can get comfortable using Python collections, you'll find Python to be a relatively straightforward experience. That should say lists. Oops, sorry. Ignore that slide. This is a new slide deck, so there's an error there. You can ignore that slide. But we're going to go through them sequentially. So firstly, we have lists. Now, again, this is just to really recap and solidify and give you a formal understanding. Lists are what are known as sequential containers or ordered collections. Essentially, what's important is that lists have an order to them. It's possible in a list to take an element and say this one comes before this one, and that's kind of how they're designed too. Like when you have a list of items, generally they have some sense of order. They were added in a certain order, you want to pull them in a certain order, maybe it's a stack or a queue, these are all ordered structures. With lists, everything is accessed via an index, and as we talked about last week, you can also use negative indexes and a few other interesting things. And we use lists in Python typically whenever we were going to use C-style arrays or C-style lists. So it's a very broad data structure and probably the most common data structure you'll interact with. One thing about lists, though, that we did gloss over a little bit last week is just how to kind of loop through lists, because looping is like a pretty looping's like a pretty hard thing to get right. And last week we talked about how you can do like a C-style loop where you essentially do for I and range the length of the items, and then you print the items. But there's actually two other kinds of loops here. The second one is what we call like a for range loop. Where you can, if a for range loop is used where you want to loop over a list, but you don't need the index. Like, what do you notice about lines 3 and 4 here? We're creating this variable I to keep track of a particular index in the list, but we don't actually need it. We're not actually using that index for anything. So line 6 and 7 makes our code even easier by just saying, you know what? Let's just like loop through this where each time I loop through it, item, the variable, is going to be the equivalent of items I. So it's just like a bit of a cleaner loop. And I can show you that code pretty quickly. We can just chat to it because we got some more code to look at. So I'm going to the lectures repo. I'm going to pull the latest master. Yep. And now I'm just going to open up my text editor which I use for lecture code. And then we should get this up. Okay, so we're currently in lecture 2.2. Oh my god, that was confusing. We're currently in lecture 2.2 in VLab. And inside that lecture, I'm going to have a look at my list loops. Right, really simple code here. Only like 8 lines. So that second one will do what I want it to. And let me just open a terminal, sorry. So now, if I go to 1531 content lectures 2.2, and I run Python 3 list loops, you'll see that I print out ABCD, ABCD, as you'd expect. So there are 2 different ways of printing out the same thing. Now, a real common thing that you might want to do, and this is just a little Python tip when it comes to lists, is you might want to sometimes print out keep track of both the index and the value itself. So you can actually use this enumerate function, which works on lists. And what this one lets you do is it actually will take a list of items, and it will let you loop through them, where each loop you keep track of the index and you keep track of the item itself. So it's kind of actually like a combination of these 2 loops. It's like you get the I from this loop and you get the item from this loop. And that's just like a way to sometimes make your code a little bit cleaner, because you don't need to, explicitly like pull out the item or anything like that. But besides that, that's most of the knowledge you need on lists. That'll carry you for like 90% of your scenarios. You don't need to like worry about way too much beyond that. So lists are relatively straightforward structures. Tuples, which we also talked about as read-only structures, and we gave you some examples of these, which were just parentheses and they're read-only. Besides that, it's all kind of the same. The 2 points I want to reiterate to you are just around when you use tuples and when you use lists. So, as I mentioned, tuples tend to be used when you're storing a kind of an ordered or a collection of unrelated data types, like maybe a number and a string, and also when they're fixed size, because you kind of never want to use a tuple if you're storing stuff that might grow in size, because it's read-only. Like once you create it, you can't modify it. Once you define it, that's the size it's going to be forever. The reason I wanted to talk about tuples again is particularly on the topic of destructuring, because destructuring is a really great language feature that exists in some scripting languages like Python, which allows you to write really clean code when you're dealing with tuples. So what I've got here is a really kind of simple example of when you would maybe interact with tuples and a few different ways of interacting with them as well. So this destructure.py here, you'll see that what I've got up the top is I've got why did that not, oh, I've only got 3 there. Okay, is what I've got is I've got a list of tuples. So it's kind of like a list of lists, because remember, tuple is just a list that's read-only, except the outer list has 3 items in it, and each of those items itself is a tuple with 2 items in it, which is a number and a string. This is kind of a standard way you might see kind of tuples in your work, right? So you got a list of stuff and then like just a little collection. It's like an easy way to group things, like a little mini struct or something like that. And if I want to go and print out all of these tuples, well, I could do it a fairly straightforward way. Let me just comment out some more code so we can see it simpler. I could go, okay, I've got my items list. I'm going to use a for range loop to go through every item in that list and pull it out. So that's like 1 tuple at a time. You can then extract the 2 elements here, because each tuple, so in each loop here, item is like one of these here. And because remember, a tuple's a list, you can actually extract information from it like it's a list. So I could say number is actually going to be the 0th element of that tuple. Char is going to be the first element of that tuple. And then I can print out with an F string number and char. So what this will give me is Python 3. This gives me, I forgot to save it. This gives me A1, 1A, 2B, 3C, right? So that's like super simple there. What you can do to clean things up a little more is you can do what we call destructuring. And destructuring is where you take something like a tuple, or essentially any kind of object that you can kind of move through, like a list or something. You can do this with a list too. And you actually have this syntax here, which is like a way to conveniently extract everything at the same time. So if I've got my item here, and let's remember that item in this case is equal to 1a, that's what it is. When I do like this weird syntax here where I say number comma char equals that, Python will actually basically pull out all those tuple items into each particular character. That's super nice because we've saved ourselves 2 lines of code, and this actually gets even better if we have tuples with more stuff in it. Because if you have even more stuff, then you save yourself writing out all these lines manually here, which just gets a little bit ugly. You can even take things further when you're doing looping, and instead of looping over an item and then destructuring it as you go, you can actually destructure it as part of the for loop itself. So you can say, instead of saying go through the items list and pull out each tuple as an item, you can actually say go through the items list and pull out the elements of each tuple into these particular variables. And this is great because it just makes things much easier to write and easier to understand. So you can see we've kind of doubled the simplicity of our work here on lines 15 and 16, which is great. Yeah. Easy done. Matthew says it should be noted that unpacking is not limited to tuples. It can be applied to any iterable object. Yeah, that's true. There's a lot more. You can take this whole topic a lot further than this. This is just like a really common place you'll see it. Like a lot of things we teach, there's a lot more to it that you can definitely go and get your head around more. Jeremy says, if you did for char comma number, would it be the other way around? Yeah, it would, because the way that destructuring works is it doesn't have a sense of what you're looking for. It just does what we call unpacking it. It unpacks the tuple in the order it sees. Like it literally just fills up from left to right. So if I run this, it'll be the other way around now. See, these last ones are A1, B2, etc. So it's just unpacking it into random variables. You can call them anything you want, but it does put it in some kind of order. The names there are not types or anything. They're just easy names. I could have called it age or something. They're just variables. You can call it 1, 2, whatever. Again, there's more I could show on this, but you know, again, we got to draw the line somewhere, I guess. Yeah, cool. Okay, well, that's kind of it on destructuring. The good thing about tuples is that they have the same semantics as lists. And again, you can do this with lists. It's just that, generally speaking, destructuring makes the most sense when you have a list of fixed size, because if you're putting an explicit number of variables there, you don't want that list size to change. So the way I think about it is like, if the collection you're using is subject to changing size, like a list of users, a list of channels in your project, don't use a tuple. And if you're not using a tuple, you're probably not going to be destructuring it like that. So destructuring, while it's not restricted to tuples, is kind of where you tend to use it, from my experience. Okay, the third and probably the most important part of this lecture is dictionaries. Dictionaries are what we refer to as associative containers, as opposed to sequential containers or collections. All these words mean the same thing, but associative means that instead of being like a series of things in an order with an index like a list, they don't necessarily always have a sense of order, but it's kind of just like this thing goes here, this thing goes here, this thing goes here, right? For people who've done 2521, it's they're hashes or hash maps. You know, there's a few different. Sometimes they'll be called objects in other languages, but essentially they're a way of mapping A to B, where A is what we call a key and B is what we call a value. Generally speaking, your key is usually a string. It doesn't have to be a string, but it's usually a string. Justin says, are dictionaries like an array of variables? I would more say that dictionaries are just like structs in C. They're essentially just a block which have a few different property names, and those property names just have a particular value. That's kind of the core of it. So they're probably most like C style structs. In newer versions of Python, I think like 3.7 onwards, dictionaries do actually have a sense of order. Though the reason I kind of want to point out that I want you to think of these as unordered, because typically speaking, because many languages don't have a sense of order for their dictionary-like structures. Generally speaking, you should treat dictionaries like an unordered data type. There is no sense like, is name first or is age first? Like, you could print it and it will come out in an order, but that does not mean it's ordered, right? Like, if I asked you for, tell me all the suburbs you've lived in, well, that actually has a chronological order in it. But you know what I mean? Like, if I was just like, can you go and get me all of the spices in your cabinet? You just kind of get them to me. You might give them to me in an order, but they're not ordered. They don't have an intrinsic sense of order. And that's kind of how conceptually you should interact with your dictionaries. But let's actually look at some examples with dictionaries. So the creation of a dictionary is what's useful about it is that syntactically, structurally, it's very similar to a list. You have some kind of creation of a dictionary, but instead of using the square brackets, you're using like the braces. And instead of using numerical indexes like 0, 1, 2, you're actually just using strings. And again, you can use other things, but let's just keep it simple for strings. And then you can print this kind of thing. And in Python, you can just print it straight out like this. So if I wanted to create a dictionary here, I can do it like this. I create an empty dictionary. I then go and populate. I say that the key name has value Sally, the key age has value 18, the key height has value 187 centimeters, and then I can print that whole dictionary, and what Python will print out to the terminal is that at the bottom. And you can see the structure of it is just kind of like, oh yeah, these are just, as we described, a series of key value pairs. These are just associations. Name is associated with this value, age is associated with this value, height associated with that value. Alternatively, just like a list, you don't have to create an empty list and then populate it. You can actually populate it straight away. So these two pieces of code, left and right, are totally identical, right? They have the same. They have the same effect essentially after line 5, or whatever. Yeah, after it's been defined. Caleb says, is there a difference between strings that are used with a single apostrophe and double apostrophe? Not in Python. No. I don't remember if there's anything to do with escapes, but essentially no. Sneha says, all keys should be unique and different from each other, right? Yeah, so this is why it's again also useful to kind of understand this like a list, because the same rules apply. Like, you can only have one value at a particular index in a list. Like, user data 1 in a list can only there can only be one user data 1 in a list, right? That's it. And same with a dictionary, there can only be one user data name. You can only have one key called name, and there's just a thing at that particular key. Instead of a number, it's a string. And you can also have multiple values. So name, age, height could all be the string Sally if you wanted them to be. Ruosong says, how can we print one container of data types in dictionary? I don't fully understand your question, sorry. Yeah. I don't fully understand that question. So if I move on to a slightly, just taking this slowly, the other thing about a dictionary is that you can create it and then modify it. So this is like a combination of the two examples we saw on the previous slide, where you kind of define it in a block, and then you can actually modify it after. Again, it's just like a list. You can kind of create a whole list inside the square brackets, and you can start modifying elements. It's the same thing with the dictionary. And Jeremy said, are the keys case sensitive? Could I, if I had an uppercase name and a lowercase name, are they different things? And I mean, we can try this out pretty quickly here too. If we go to Dictionary Basic 2, I could actually just add another, B-Lab's a little bit slow. I could actually just do this. Let's see what the outcome of this is. And it's going to be the same here. So if I do Python 3, dict basic 2, you'll actually see they are different names. And that's because they are different strings, because lowercase, uppercase are different ASCII characters. So it's like they are different strings. They are not identical strings. If you try to check in Python, are those two strings the same? Python would say, no, they're not the same. And because they're not the same, it's like, okay, well then they're going to be different keys in this particular case. Sorry. Okay, that's all well and interesting, but let's actually have a look at printing out some dictionary items, because that's kind of where things get even more interesting. What I've got here now is like a compound collection. It's like I've got a list of dictionaries, right? So we know lists, we understand dictionaries. Now I've got a list of dictionaries. Previously we had a list of tuples. So you can tell it's a list of dictionaries because we've got, you know, the two square brackets which imply list, and then inside of that we have two elements in the list which happen to be dictionaries with two different sets of data. They both have name, age, and height. Now let's say I want to print this out. How do I print it out? Well, I can use two for loops, right? Because my data structure is two levels. The first for loop is going to loop through the list. That makes sense. I'm going to loop through the user data. For each item in user data, I want to pull that out as a variable user. And then what I can do is I can try and print that user. So let's just print this out as it is. So we're just going through the list now. So when I run Python 3 dict loop 1, it says the whole user's name, Sally, age 18, height that. So I'm actually printing out just that whole dictionary at the moment as a blob, right? Just a whole blob. But then let's see what happens if I want to loop through that dictionary. So if I want to loop through that dictionary, which is this item here, I can maybe, let's try and use a for range loop again. So I'm going to say for each object in my user here in the dictionary, I'm going to call that part of my dictionary. Why not? And then I'm going to try and print out that part. Let's see what this does. Okay, so this is a little bit weird here. So what it's done is it's printed out for both items in my dictionary. It's printed out name, age, height, but I don't want that. So what it's doing is it's printing out the keys. And this is really important because this is the default behavior of Python generally. It prints out the keys when you loop over it. It doesn't print out the, what would you say? It doesn't print out the values. So if you want to print out the value, how do you get the value? Well, it's the exact same again as a list when you're iterating over indexes. You just call the list with a particular index. So in this case here, if I want to get the value, I could just print out user part, right? Because part's like my index. It's a string. It's how I access it. So now what this will do is this will give me this here. Name users is not defined, right? Because I used a S there when I shouldn't have. Then like bam. Okay, so now what happens is we have this particular like user and then like Sally 18, 186. So we're actually printing out these values now. And if I wanted to print out the keys as well, I could say do something like this. I could use my F string and say that part is that particular value. And now we get something nice like that. So that's kind of like a basic way that you would interact with a dictionary. The last thing on dictionaries before we can answer some questions on them is that I mentioned before the dictionaries by default, when you just use a for range loop over them, they give you the keys. You can actually use other built-in functions on a dictionary object to get different things from them. So for instance here, I can actually get the items when I loop over it, or I can get the keys when I loop over it, or I can get the values. Now, items is the key value pair, keys are the keys, values are the values. So if I just print this out here, you'll see what the result is. Python 3 dict loop 2, right? When I loop through items, I get you know, name is Sally. I actually get these as tuples. So what the dictionary does when you loop over the items object here is it gives you tuples of the key value pairs. Right? Great use case of tuples. Non-modifiable, read-only, potentially different data types. And when you do keys, you get the normal behavior. So this loop is actually indistinguishable from the normal just for user in user data. And then if you do the dot values, you actually get the values. Generally speaking, I would say that most times you loop through a dictionary, you care about the key a lot. So you're probably most likely either just going to do a normal for loop, or you're going to do like an items for loop like that. And just like we saw before with destructuring, because this is a tuple, we could break this out too and say for key value in that, and then we could print this out even clearer. We could say, you know, key is value. So that's like that is like the most compact way, for instance, of looping through a dictionary. Now you get something like that. Okay, are there any questions about dictionaries? We might even have time to move on to our importing lecture, which will free up a little bit more time tomorrow for us, which is good. Rusong says, I mean, if we have two people in the dictionaries and we want to print the information for the second person, what should we do? Well, if I go back to, say, dict loop 1 here, you could print out the name of the second person just by saying print user data 1 to get the second item in the list name. And that would print out Bob. Right, it would print out Bob. So the interactions with it, again, are very, very similar to your interactions with lists. Can you name a dictionary by giving it a string? I don't fully understand what that means. Art says, can you use dictionaries to implement auth register? Yes, you can. That's why we talked about it in week 1 a little bit. So you were just kind of like loosely familiar with it. And we said we'll talk about it in more detail today. It's definitely critical for the project. Lists and dictionaries are a big part of the project. Lance says, how do we insert new name age into a dictionary? .append. Well, that's a good question, because inserting into a dictionary is probably the one biggest thing I think that's different to inserting into a list. Inserting into a dictionary, you can do so just by actually like populating it. So for instance here, if I wanted to say add a new property to user 2, right, I could just say the new property might be like score equals 90. I can actually just add it straight in. There's no append because it's not ordered. Like, you can't append to a dictionary because it's not ordered. Like, appending means add to the end, but there is no real sense of end. It's just a collection of key value pairs in a big pile. So now when I run this again, you'll see that Bob actually got that score added as 90. So adding to dictionaries is actually really, really easy. Will enumerate do anything to dictionaries? Enumerate takes in a list. That's what enumerate does. So a dictionary is not a list. So enumerate won't do anything to dictionaries. That's the short answer there. And Tuaka says, just bumping a question from earlier. Oh, this is an unrelated question, but should we switch to the master branch prior to pulling from Git, or is it okay to pull directly into the branch you're working on? Either's fine. I just didn't want to demonstrate the latter one because I think it makes everything, it can make everything very confusing if you don't know what you're doing. So either's fine, but the way I like to teach it is to always try and pull into the branches you have, because then it's like you just have it all there, and it all kind of makes sense for people trying to get their head around it. The last thing on this topic is sets. Sets are exactly what you'd expect. They're like dictionaries, except they have no values. They're just collections of keys where you can't be repeated. They are quite literally sets without value. Sets are quite literally dictionaries without values. You can go and have a look at, I linked you to some Python docs here. You're all very smart by virtue of the fact that you're at university and you've already done a course on this, and we've already been talking about different data structures. So you can actually like just have a look at this set documentation if you need. Generally speaking, you probably don't need to use this much in the course at all. That's why we aren't talking about it in any detail, but you know, it's all pretty straightforward to get your head around. You know. Yeah, so like Matthew's gone and talked about enumerating working on a dictionary because the dictionary is also iterable. There's a lot of subtleties here around how objects work and iterables and what classes are, you know, and it's just something I'm not going to go into excessive depth on at the moment. That's why I kind of was really clear that enumerate works on a list, not a dictionary, but that doesn't mean that a dictionary can't provide you with a list. Like we saw this already where we iterated in this example over here over the values. So this here actually returns you a list. So the point is that enumerate works on some kind of list function, some kind of list object, sorry. So the question, can you enumerate over a dictionary? No, but you can represent parts of a dictionary or the whole lot of a dictionary as a list, and you can enumerate over that list. So enumerate is for lists, but you can convert many objects from one type to another. And you'll kind of stumble upon this naturally as you play around with things. And again, there's a lot to take in the first couple of weeks. So we could take all these things 4 times further, but we just again draw the line somewhere. So that's pretty much it. I forgot to do the feedback for. Oh no. Okay, that's okay. So it would be great if you could leave some feedback for the collections lecture, just where we talked about, we kind of tied off the loose ends around lists and tuples and dictionaries. If you're also there and you could be bothered, it would be great if you could fill it in for the Git lecture as well. If you could just refresh the form when you're done and be like, yeah, that's what I thought of the Git lecture. What we'll probably do for the last 15 minutes, so please pause the video and fill that out, that would be great. What we'll probably do for the last 15 minutes is talk about just a little bit on importing, because we probably have the time, and even if we don't finish it, we can just touch it off tomorrow. But let me just stop the recording because we're moving on to the next lecture.